Okay, so this is a short video on a recap of right-angled trigonometry, and you might know this as SOHCAHTOA. Now you need to remember how to spell SOHCAHTOA. That's important. I always have three little rhymes. SOH, I always remember as schools offer homework. Schools offer homework. And I always remember TOA as teachers offer assistance. And the middle one I always remember as something controversial, two Class A drugs that I will let you fill in yourself. Okay, so first of all, SOHCAHTOA only works for right-angled triangles. You must remember that. If it is a non-right-angled triangle, then you have to use the sine and the cosine rule. So remember, SOHCAHTOA is only for right-angled triangles. Don't forget that, please. What do these three letters mean in each of the SO, the KA, and the TOA? Let's just remind you of that. Remember that the SO means, and sometimes you might see this written as oops, I'm trying to stop this. By just getting a crash here at the moment. Hopefully it will recover. So stands for the S stands for the sine of an angle, and we usually write sine as SIN, not sin, but still pronounced sine, of some angle. We could call the angle theta or A or B, doesn't matter, let's just use A perhaps. The sine of an angle is the O, stands for opposite, and H stands for hypotenuse. And for KA, the C stands for cosine, cos or cosine of an angle is equal to A, stands for adjacent, and again H stands for hypotenuse. And TOA, the T stands for the tangent of an angle, and this is the opposite divided by, and A again stands for adjacent. Okay, now you must remember those, they're very important, what they stand for. But what do they mean? That's the next question. What do they actually mean? Well, in order to answer that, we really need to draw a triangle. So let's draw a triangle here, a right-angled triangle. And let's say our angle here is A. Now, the important thing to notice in all of these formulae, so for example, here, the sine of A means the sine of an angle A and the cosine of A, the cosine of an angle A, and the tangent of A, which is the tangent of the angle A. None of these make sense without referring to an angle. So there's no such thing as sine on its own, there's no such thing as cos on its own, and there's no such thing as tan on its own. There must always be sine of A, or cos of A, or tan of A, or perhaps sine of B, cos of B, tan of B, some angle. And the reason is that for example, opposite has no meaning unless you say opposite what? Well, it's opposite the angle that you're interested in. So this side is the one that's opposite the angle. Okay, so let's just put that in there. So let's just put that in a different color here. This is the opposite. Okay, that's the opposite. Now the hypotenuse is always opposite the right angle. Remember that. So hypotenuse is definitely there. Always opposite the right angle. And the one that's adjacent is the one that's touching the angle. So this is the adjacent side here. It's touching the angle, or adjacent to. Okay, so that's SOHCAHTOA. Let's do a quick problem on SOHCAHTOA. First of all, we're going to look at finding missing sides. Finding missing sides. So let's have an example that looks something like this. And let's say we want to try and find this missing side A. Sorry, let's call it A actually. And we'll call our angle capital A. Remember, our sides are usually small letters and our angles are usually capital letters. And let's say we're given that angle A. So our angle A, let's say this is 30 degrees. And let's say we're given the hypotenuse here of 20 centimeters. And our job is to find A. And this is the process that we should go through. The first thing is place ourselves on our angle. So our angle is here. So we're looking at our angle 30 degrees. And we figure out from that angle which side is which. So this is the hypotenuse, because it's always the longest side and it's always opposite the right angle. So that's the hypotenuse, the 20. The one that's touching the angle is the adjacent, and the one that's opposite the angle is the opposite. And we need to remember to write down SOHCAHTOA. So we're going to do that. So one of the first things that you should always do. So we'll write down SOHCAHTOA. And we're going to tick what we know. Okay, so looking at what we know the hypotenuse. So we're going to tick the hypotenuse, the two H's. That's 20, so we know it. And we also want to involve the A, because we need to find the A. So that's the opposite. So we're also going to tick the opposites. And where we've got two ticks on one of the three acronyms there, that's the acronym that we're going to use, or the relationship that we're going to use. So we're going to use this SOH, which tells us that the sine of the angle that we've been using, which is 30, is the opposite, which is A, over the hypotenuse, which is 20. And we want to find A, so we multiply both sides by 20. And then we use our calculator to find the sine of 30. So let's just go to our calculator temporarily. I should have it here actually. 1 second. Where is it? Actually, I can type it in here, I think. Now, sine 30, as you'll see at the top of the screen there, is a half, and we'll come back to that later because that's important. So this is a half times 20. So if you do sine 30 on your calculators, 30 degrees, you will see that we always get a half. So a half times 20 is, of course, 10, and the units will be centimeters.